So in this case, I want us to consider our typical exam question, which is from our August exam, which was written actually in on 20 July 2024. So we're just gonna quickly rush through and see what the questions were all about. Remember that you're supposed to read all the instructions that you're given and make sure that the calculations are done properly. That is the major part that you're gonna have. So in this case, number one, it was actually on the graphs where you need to know the part of the sketching, the drawing of the graphs that you are given. So in this case, you are given the first question, question 1.1, to draw a neat graph of y is equal to minus x cubed. That is a cubic function. So how are we going to obtain this function of y is equal to minus x cubed? Okay, that's 1.1. Y is equal to minus x cubed. So remember, this is a cubic function, which is just opposing the normal cubic function that we are used to offer y is equal to x cubed, which is like this. Remember, the one of y is equal to x cubed is like this in the positive way. So the one of minus x cubed, this one, is the one that is going to be in the negative region, right? So this is the one that you will obtain in the negative region. It opposes the one that you are used to in this negative region. So this is what you're going to have approximately, something like that, okay? So that is passing through the point 0. That is y is equal to minus x cubed. You can just even have points for this. It's just points to apply this. You can just have points that you can just use. Okay. In this case, you can just say, okay, let's just say we've got our table. Too much points there. You do not need too much points. Just a few points can just indicate -3, -2, -1. Okay, then you move on to a 0 in this case, to a 1, a 2, a 3. Okay, these are actually enough. So what you just need is to substitute these values. Okay, this is y is equal to minus. You substitute the value of x when it is -3 raised to the exponent of 3. Okay, so this was going to be a positive 27. Okay, this was going to be a positive 8, a positive 1, a 0 there, a negative 1, a negative 1, a negative 8, a negative 27 when substituting these values. So with this, we can see, okay, with the values that we have, we're just going to indicate, let's just say something like this, guys. Let us just have a smaller Cartesian plane to represent. So that's our x and y. From the x values, we can just indicate, let's say this is 0, this is 1, this is 2, this is 3, and -1, and -2, and -3. And on the corresponding values, you can just use 5, 10, or you can use any scale that you are capable of. Okay, so let's just say 5, 10, 15. Okay, let's just even use 10, guys. Whatever that you want. So let's just say this is 10. Oh, this is 20. Oh, this is 30. Okay, this will be -10, -20, and that will be -30, so that we can have these values, the major values, the -27 and +27 there. So approximately, we're gonna have something like this: -3 versus 27, which is maybe somewhere there. -2 versus 8, it's going to be just below 10. -1 versus 1, maybe somewhere here, the 0 and the 0. 1 and -1, we're now in the negative region. The 2 and -8 in the negative just before -8. The 3 and the -27, something like that, just below -30. So you can see that, okay, this is the function. So that I'm supposed to join this point, something like this. All right, so you're going to have something of this nature. All right, yes, just that, guys, cannot have that accurate thing as you guys are going to have. So make sure that you know the shape. The major part is on the shape. Okay, that's the major part. What are we supposed to have there? That's why it's equal to minus x cubed, just like that. Okay, so let's see. From this, draw a neat graph of an inverse of this function. The inverse. Take note, the inverse. Okay, let's talk about the function first. We are given 1.2. The function is given as y is equal to x squared minus 4. But what we need from this function is its inverse. Its inverse. How do you find the inverse? So the inverse is simply, you can interchange the x and y values, then you make y the subject. So you interchange first. So meaning to say x is equal to y squared minus 4. You interchange the x and y. Then you make y the subject. You make y the subject. By making y the subject of the formula, that's the inverse of the function that you've determined. You're determining the inverse of the function. So what are you going to have? If you make y the subject, negative 4 to the other side, crosses the equal sign, that's a plus. So x plus 4 is equal to y squared. So what is the value of y there? Just going to introduce the square root, both sides. So meaning to say, y in this case is representing the square root of x plus 4. That is our inverse. Whereby the square root of any number, we do understand that's a plus or a minus. So we are going to expect two possible values for each x value that it is being inserted. And as we do understand that we cannot obtain the square root of a negative. So our x here is limited to minus 4, which is when you equate this, x plus 4 is equal to, our x is limited to minus 4. When I'm saying our x is limited to minus 4, I'm saying on the Cartesian plan, when you are to present your graph, okay? You are to present your graph. The x values, it will be minus 4 here. That is your limit. You are limited to negative 4 going to the positive. You cannot have any value this side of minus 4. You cannot have. Try to put a minus 5 here. Square root of minus 5 plus 4 will give you square root of minus 1, which you cannot simplify. You can simplify any value from minus 4 going to the positive. Think of any value in that region. Is it minus 3? You can simplify this. Minus 3 plus 4, that's a 1. Square root of 1 plus or minus 1. You can simplify anything from that side. So that is the idea there. So as we can see, for each and every x value that is being inserted from minus 4, going to the positive, it is going to give us two possible values. One on the positive region, another one in the negative region. One in the positive, another one in the negative. One, and so on and so on. So this is what you're going to have. You're going to have a function of this nature. It is giving us two possible values at each point, where the x-intercept will be at minus 4. So what is important is made for you to understand, okay, x-intercept and the y-intercept. So that will be the most important thing. So already the x-intercept is our limiting point at minus 4. Because at minus 4, it will give you a 0 there. If you substitute minus, remember we limited that so that it will give us a 0. So you're limited at minus 4 and 0. So what about the y-intercept? Because we have got the x-intercept. The y-intercepts, because there are two possible values that you can have for y, are at a condition where x is equal to what? To 0. for the y-intercept. So when x is equal to 0, what are the y values? Y is going to be equal to plus or minus the square root of 4, which is plus or minus 2. So we have got the y-intercepts, two possible values, one on the positive, another one in the negative region, a positive 2 and a negative 2. This was going to give us the function, which is the inverse of what we had. That's it. So this is the inverse, and the equation of the inverse is this one. Y is equal to plus or minus the square root of x plus 4. You have the inverse of the function. So they will test you like that. Need the inverse first. Then what type of a function is that? Draw a neat graph of xy is equal to minus 4. All right. Xy is equal to minus 4. What type of function is it? That's 1.3. Xy is equal to minus 4. You are now talking of a hyperbola. If you understand this function, you see that xy, when it is equal to, it can be plus or minus a, where when it is a positive a, we do understand that this is how our function is going to be like. In the positive region, and another one in this region, in the first quadrant, another one in the third quadrant, when it is a positive. When it is a negative like this, we are going to have our quadrant like this. We're going to have our graph in this second quadrant and in the fourth quadrant. That's when it is a negative. So do not worry about this 4 that you're seeing there. The constant, then whether it's a minus 10, it's a minus 20, guys, the shape is going to be the same. What is important? What are you having there? So they can give you this function as xy is equal to minus 4, or they can give us as, if you divide by x, it means y is equal to minus 4 over x. Still, it's one and the same presentation. As long as we've got a negative, it means our function was going to be in those quadrants. So that is the idea there. That is the whole idea of this hyperbola concept, because it's a negative that we have. So meaning to say, you're going to have this as your x and as your y at the point 0 there, just like that. In these two quadrants. So you can just write the equation xy is equal to minus 4 at any point. You can write here or in this one. These are functions that you can have. You can have a table presenting, right? Any function that you're given. The moment that you forget the presentation, present it in the form of a table. Y is equal to, we divided by x, we got minus 4 over x. Okay, as we can see from this function, x is limited that since it is in the denominator, it is limited that it cannot be equal to 0. That is why you see even on your presentation, your graph was not passing through the origin. It was like this. That is, we have got an asymptote there. It cannot reach that condition. It cannot reach that point. And if x is not equal to 0, it is also affecting the value of y. It is also affecting the value of y, meaning to say y cannot also be equal to 0 again. So that's why you see our graph is not passing through the y like this. No. It is maintaining within the quadrant. It cannot reach the y, it cannot reach the x. So y cannot be equal to 0, x cannot also be equal to 0. So if it is like that, we just choose points of your choice, which are not to be 0. but surrounding this. So many say if they are surrounding 0, we are going to consider from 0 going to the positive. That's 1, 2, okay? And you can just take maybe a 4, which is enough. To the negative side, you can even take -1, -2, and -4. All right, I'm just choosing numbers that we can easily divide because there is a 4 there. So you cannot choose a number like that, but it's fine. You can choose it, guys. It's not a problem. Here I'm just like choosing the values that we can easily divide. So remember, these are our x, these are y values. X is -4, you substitute there. -4 over x, which is, you're going to divide by each value. So this will be +1. If you divide by -2, a +2, by -1, a +4, by 1, a -4, by 2, a -2, by 4, a -1. This is enough for you to even see how the graph is going to look like in terms of maybe you have forgotten your presentation. The table is not gonna limit you. So this is your x, this is your y there, and you can just write your points. That's 1, 2, 3, 4, and so on. -1, -2, -3, -4. So the y value is also going up. 1, 2. Let's say I've got 1, 2, 3, 4. The x, the y in the negative. All right. So that's something like this. -4 versus 1. That is -4 versus 1. -2 versus 2. You mark your point. -1 versus 4. You mark a point. You are done in this region. So you can even join these points. You move on to the other side in the positive. On the positive side, that's 1 versus -4. 1 and -4, 2 and -2, 4 and -1. You mark your points. Then you can join them. You have your graph. So with this, you're not going to have any complications to say the graph is going to be in which quadrant or what. The points alone will give you the exact positions. You can see that the points, they are in exact quadrants that we expect our graph to be in. So that's our hyperbola concept there. All right. So let's check another part, which is 1.4. Draw a neat graph of y is equal to plus or minus the square root of 16 minus x squared. All right, that is for 2 marks. Okay, what are we having there? So the question is, what type of a function is that? What type of a graph are we having if y is equal to plus or minus the square root of 16 minus x squared? So this is simply a presentation of a circle. When you are given a plus or minus there, it represents a whole or a complete circle. If y is written in this format of plus or minus the square root of r squared minus x squared, that's the equation of a circle. Okay, look guys, where was it taken from? Remember, x squared plus y squared, this is what you're used to do, is equal to what? R squared. This is the equation of a circle, isn't it? That's what you are used to. Okay, let's make y the subject. Y squared is equal, because y is the subject there. So you just make this and see if it is going to give you this presentation. So take this to the other side. It was going to be a negative. That's r squared minus x squared. Remember, you want to make y the subject. So you're going to introduce the square root, the square root. So that was going to give us y in this case, which is equal to the square root of this, where we know that the square root of any number is what? A plus or minus. Isn't it what we have in this presentation? This is exactly the presentation that we have, which is here. So that's a complete circle. If it is a half circle, they will put one of the signs, either a plus or a minus. But in this case, there are 2 signs. So that is to show us we've got what? A complete circle. So as we can see, that this is a circle where the radius is given r squared. So meaning to say from this 16, what is our radius? How can we write, how can you write 16 as a number to the power of 2? You simply need the square root of 16. The square root of 16 is 4. So meaning to say, this here can be written as y is equal to plus or minus the square root of this 16 as a number raised to the power of 2. The square root of 16 is 4. So that's 4 to the power of 2. If you raise this to the power of 2, it will give you the 16. So that 16 is same as 4 squared minus x squared. So from this, we can simply tell that our radius, this one is 4. So radius is equal to 4 units. The center, this circle that we are given, that we presented x squared plus y squared is equal to r squared. It is centered at what? At the origin, 0, 0. So the center is 0, 0. With this, it's enough for you to present your graph, because you know that the radius is the distance. This radius is the distance that is taken from the origin, from the center. So if this is our x and this is our y like this is our origin. From the origin, we have got 4 units as our radius. Remember, a circle, guys, is like this. So we have got 4 units to the y, 4 units to the x, 4 units to the minus, 4 each and every part. It will be 4 units. That's the radius from the origin. So this alone will give us a circle by joining the points that we are given. It is going to give us a circle. So that was the whole presentation there. So you can just maybe indicate your circle and mark the points. So this will be at positive 4 and minus 4, at positive 4, and this side minus 4. The radius, guys, the distance from the center to the circle here, the distance is 4. Every distance that you make from the center to the what? To the origin, from this origin to the circle, as long as you are moving from the center to the circle, the radius, that is the distance there. So that's our circle. Okay, that is gonna be 16 minus x squared. You just write your equation. Or you could have just used a normal presentations of the x-intercepts and y-intercept if you are used to that. Remember, I also talked about that on the revisions to say any function that you can be given, which is as long as you're not considering to say maybe it's a hyperbola, but considering a circle and other functions, you can work with the intercepts. The x-intercept, what are the conditions for us to have this? Y is supposed to be equal to 0. Okay, so let's substitute here. If y is equal to 0, what are we going to have? That is going to give us 0 is equal to plus or minus the square root of 16 minus x squared. Okay? So from there, we can make x the subject. So for x, plus or minus is no longer effective because whatever that you divide there, 0 divided by any number, guys, whether it's a plus or it's a minus, it will remain what? As a 0. So the plus or minus is no longer effective because there's a 1 here, guys. So what I'm simply saying is that, let's say you divide a 0 divided by plus or minus 1. 0 divided by plus 1, that's a 0. 0 divided by minus 1, that's a 0. Whether it's a minus there, whether it's a plus, as long as it's 0 divided by any number. So meaning to say the plus or minus there is no longer effective, as you can see from your mathematical view. So the plus or minus is no longer effective. So what can we simply do? Square both sides to remove the square root. So you're going to square both sides. That's 0 squared is equal to 0. The square root raised to the power of 2, thus we're going to remain with this part under the square root. 16 minus x squared. So let us find x, transpose the x squared. To the left-hand side, it was going to be a plus. It was a negative, so it will be a positive. X squared is equal to 16. So to determine the value of x, simply introduce the square root, where x is going to give us the square root of any number that's a plus or minus. So x is at plus or minus 4. You do the same thing for the y values, the y-intercepts. Okay, you do the same thing, which is at a condition where x is supposed to be equal to 0. So you just substitute the place of x, you can determine the value of y. So as you can see, y is the one that is limited to plus or minus. So it's plus or minus the square root of what? X is a 0, z. So that's 16 minus 0 squared, which is simply a 16 there. And the square root of 16 is what? Plus or minus 4. So as we can see, the value of x and the value of y is the same. So that simply means that's a circle that we are having, even if you do not know the type of function that you're going to have, by just seeing the x and y values being the same. To say from the origin, x is, the y is at 4, and another one at minus 4. The x is at 4, another one is at minus 4. That alone is telling us that we've got what? A circle. So that is another way that we could have just drawn our circle using the intercept concept. Okay, so you're going to use the intercept concept. X-intercepts, you calculate the y-intercepts. So the intercept concept, they're important, especially when it is now a half circle. Like I said, they can give you like a plus there. They are limiting you to say y is only limited to a plus. So if y is limited to a plus, we cannot have this as a complete circle because y is no longer in the negative. We are now having this as a what? As a half circle. You'll be having it as a half circle. So you must consider what is given there. But in this case, it was a plus or minus. So meaning to say, whatever that you're having there is a complete circle. So I just hope we are together on this part. Let us check another part of our question, which is on question number 2. So question number 2, you're given to simplify the following. All right, so let's see what we are given there. 2.1. Simplify the following. 2.11, we're given 3 minus 2j to the exponent of 4 and express it in polar form. Okay, so whatever that you're given is supposed to be given in polar form. Remember your polar form, r angle of theta, like that. So let's check what we have, guys. This is 2.1. So you're going to have this as 2.11. So we are given 3 minus 2j to the exponent of 4. So this is when you're given this, remember your presentation that it is easier for you to raise a certain a certain complex number to any exponent when it is in polar form. Remember from our demofs that r angle of theta, when raised to the exponent of any like that, it can be simplified as r raised to the exponent of n and this theta multiplied to n. So it'll be r to the exponent of n and the angle is multiplied to n. So it's n theta. So meaning to say the presentation here on its own is supposed to be in polar form. So how are you going to convert to polar form? Remember on your presentation this, so that the angle there we are accurate enough to obtain our angle. This is the real part, which is 3. So remember your real axis, imaginary axis. So the real part is at positive 3. So you're going on the positive side. Okay, so let's say this is 3. The imaginary is minus 2. So this is negative 2 like this. So as we can see, these two, they are in the 4th quadrant. So this is what you're going to have where these two meet in the 4th quadrant. They are found in the fourth quadrant. So why is this important? It is important on the angle now to be taken. It's either you're going to take this angle or you are going to take this angle inside. So taking this angle inside, it will be a negative. As you can see, guys, remember your angles going in clockwise, they are taken as negative angles. In the anti-clockwise as positive angles. Remember that. So this angle is going to be a negative. So it's going to be up to you. So I'm just going to use this one inside the acute angle. So that is how you're going to have your diagram. So everything does not change, guys. To remember, your R there is equal to the square root of a squared plus b squared. Okay, from our Pythagoras theorem. So our a and b, that is the square root of 3 squared plus minus 2 squared. So that was going to give us the square root of 18. Okay, let's just hope I did simplify this one properly. Then you do the same thing, calculate the angle from our angles. Remember, opposite over adjacent from our arctan. So theta is arctan opposite, which is minus 2 over 3, which was going to give us something like negative 33.69 degrees. So this is it. You need to work with the angle of your choice. It's either you're going to work with this or you're going to work. That's why I presented that diagram. So the negative angle that you're seeing is this one inside the acute angle there, which is enough for us to use it as it is. You can use the negative, you can use because they are equal. So it was up to you. So how are you going to obtain the remaining angle? So the remaining angle, it was going to be 360 minus this one of 33.69. That is the other, the rest that you are seeing there, and which is what? Which is a positive. So you're going to find the difference there of 360. Then you subtract 33.69, which was going to be something like 326.31. So it's still one of the same thing, 326.31. So you can have it like that. As a positive as it is, you can have it like that. Or you can have it as a negative. They will mark according to the angle that you've used it. All right. So us using this negative angle, it's fine. And our R there, this is going to be, we are just rewriting this in polar form. So meaning to say, this whole simplification that we're given here of 3 minus 2j to the exponent of 4, the whole of this part that we are seeing here raised to the exponent of 4 is the same as in polar form, that's R angle of theta, which is our R there, the square root of 18, the angle theta, which is negative 33.69 degrees. Raised to the exponent of what? Of 4, which is the power there. So if it can be written in this polar form, remember that it can be simplified as R to the exponent of n. What is our R in this case? That's the square root of 18. So it was going to be square root of 18 raised to the exponent of 4, which is this part. R to the exponent of, what about the angle? You multiply it by n. So the angle is going to be multiplied by the exponent, that is n theta. So we multiply 4 times what? The angle. 4 times negative 33.69. So that is it. So this simplified was going to give us 169. So we've got 169. And the angle, you multiply it, was going to be negative 134.76. So just also use your calculator to verify if we are on the same page, because guys, you know, if you're working with the calculator, you can just make simpler mistakes. So also verify with your calculator. That's the simplification. So you need the conversion for you to apply the exponent, which is what? The d moles part. So let us check another part, which is 2.12. On 2.12, you're given expressed in rectangular form. Whatever that you're going to have here, our answer is supposed to be in rectangular form. Okay, let's check our question, 2.12. So in rectangular form, remember you're maintaining your normal format of A plus or minus JB. Okay, that is what you're maintaining. So you are given, in this case, you're given 2 plus J into the bracket minus 4 plus 2J like this, everything over 3 minus 2J like that. So as we can see, there's a division where we need to now apply the concept of making this to be a real term complex conjugate. But let's get rid of the top part, our numerator there, because there we need to expand the brackets. So distributing first bracket, this one, we're going to expand it. So meaning to say 2 is going to multiply everything in this second bracket. 2 multiplies minus 4, which is going to give us negative 8. 2 multiplies the 2J. So 2 times 2, that is going to be a 4J. You're done with the 2. You move on to this J, plus J. So this is plus J times 4, which is going to be what? Plus and minus, that's minus. So that's minus 4J. The plus J multiplies the plus 2J. So what are we going to have? Plus and a plus, that's a plus. So it's going to be 2. A J and J will give us what? J squared. Everything over 3 minus 2J. As we are simplifying this, the J squared, we do understand that it is equal to what? Minus 1. So you will remember this. So if J squared is equivalent to minus 1, it means here, this part here that we are seeing here, this part is going to be represented with minus 1. That is the whole idea, this part of J squared. It is now represented by a negative 1. So meaning to say, guys, we can simplify this and have minus 8. Since there is a minus 1, so it's now minus 8. 2 times minus 1 is what? It's minus 2. So that will be minus 8 minus 2, which is minus 10. The plus 4J and the minus 4J, these two, they cancel. 4 minus 4, that's a 0. So this cancels. So this is what we are having on top here. We have simplified. Minus 8 and minus 2. Everything over what? The denominator, which is 3 minus 2J. This is what we have. So in this condition, you're supposed to ask yourself, remember, you're supposed to maintain the rectangular form. So what is it that we're supposed to do here? The denominator is not allowed to remain with this J. The imaginary term is not allowed in the denominator. In your simplification, the denominator can be written in the numerator, which is fine. But having a real term in the denominator. So how can we get rid of that, since this is not allowed to have a J in the denominator? We have the imaginary term. So we are going to use the complex conjugate. 3 minus 2J, its complex conjugate is going to be given as what? 3, you introduce a negative on the imaginary term. That will be a positive 2J. So you multiply both the numerator and the denominator by that complex conjugate. This is our normal complex number, and this is its complex conjugate. So that once you expand this, the denominator now will be a real term, which we can expand our brackets here, guys. As we can see, -10 is going to multiply this as it is. So that's -10 into 3 plus 2j over what? This expands. So it's a bracket. So this was just like 3 minus 2j like this into 3 plus 2j like that. So I'm going to explain two concepts here. If you multiply a complex number like this and its complex conjugate, z, a complex number, it's a plus jb. Its complex conjugate is given as a minus jb like this. It follows that the product of these two, z, complex number, and its complex conjugate will give us a real term. That's why we're doing this, which is very true that we're going to have a real term. We are not going to have a j there. We are going to have a real term. And that real term that we are talking about is given as, you just take these terms, guys, the a and the b that we are seeing. Remember, this is the same. A, this is b. A, this is b. The only difference is that there's a plus here, there's a minus. So it's like a difference of two squares. But on the difference of two squares of the complex numbers, this is how you simplify them. It will give you a squared plus b squared. A squared plus b squared. So the product of z, a complex number, and its complex conjugate is equal to a squared plus b squared. So if I'm given this is our a, this is our b, this is our a, this is our... So the complex conjugate there is simply to square, guys, the number, the 3 and the 2. That is the product of these two. A complex number and its complex conjugate, this one. It can be simplified straightforward, this one that we are seeing here, from a squared plus b squared, this one. Our a is 3, so it's just going to be 3 squared plus our b, which is 2 squared. As it is like that. For complex, we don't use a squared minus b squared, unless if you use it as minus jb squared like that. It will be minus, but don't use that so that you won't have challenges. Just use it as a squared plus b squared. So we have simply, that expanding of brackets, we can expand your brackets there. Still, you can have the same thing. You expand this 3 times this, 3 times this, minus 2j times minus 2j, that you multiply, just like how we expanded this one. If you still remember here on top here, you are still going to have the same answer as this one. Okay, so let's focus on the numerator there. Minus 10, because these ones, they are not the same. So they are not like a number in this complex conjugate. So there you have to expand properly. Minus 10 multiplies the 3. That is going to be what? Minus 30. Okay, minus 10 multiplies the 2j. That is going to be minus 20j. This is where you are. So instead, guys, of expanding, like I'm not saying it's wrong. No, I'm not saying it's wrong. But I'm just saying that if you have this condition, even under your normal simplification, that you can see it, because it's not always where you are told or where you can say this is the complex conjugate. You by just looking into how the presentation of the numbers are, we are given 4 plus a j like this. Another bracket, it has 4 minus a j like this. What does it tell you? This is a normal term. We introduce a negative on the imaginary term here. That this makes the other bracket to be a conjugate of another one. One bracket is a conjugate of another one. So if we say this is our z, a complex number, this is its complex conjugate. Or if we say this is our z as a complex number, it means this one is the complex conjugate, no matter the way that you view it, but a product of a number, of a normal complex number to its conjugate can be given from that formula that I said. You can simply use a squared plus b squared. So our a is 4 in this case. So this here can be written as 4 squared plus b squared, which is the number that is affecting j. There's a 1. There's a 1 here. Don't focus with the sign. The number there, it's 1, it's 1. So it's going to be 1 squared. So this is going to be 16 plus 1, which is 17. Guys, if you expand these brackets the way that you are used to, you see that you get a 17. So this is what I'm trying to say. To say it's an advantage for you to understand this. Yes, you can do the normal expansion of brackets. Okay, so let's simplify. Negative 30 minus 20j over what? 3 squared plus 2 squared. That is going to be 9 plus 4, which is 13. So that was going to give us 13. So this is what we have as our answer. But as we're given, that is supposed to be a rectangular format where we can even separate to see what is A and what is representing the part of JB, which is our imaginary term. So the real term, we're just going to separate this denominator with minus 30. This one we also separate by 13. Minus 30 and 13, minus 20j and 13. It is the common denominator of these two. So you can write it as minus 30 over 13. The remaining part as minus 20 over 13j. You can even write it as a decimal. It's up to you. So we can properly see that there we have got our A and the remaining part of the JB that is there, which is showing us the imaginary part and the real part separated. So the real versus the imaginary. So that is your expansion there. How to expand the brackets. It's very, very important. If you cannot notice this part of a complex number and its conjugate, and you can realize this, it can save you time in exam. That can save you time. All right. So that is what we had there. Let us check another part for the complex numbers. We also have 2.13. All right, that's 2.13. We are given to express this in the form of A plus JB. Okay, we're back again to the rectangular format. So how can we simplify this whole part? Okay, let's check what we are given there. Let's check and see. So this was given as 2.13, where we are given 3j to the exponent of 6 minus j to the exponent of 16. Everything like this is over 1 minus 2j. Okay, this is what we have. And express it in the form of a plus j. We are supposed to express it in this form. Let's see what we have. Remember that we have got the j squared that we are used to in terms of exponents, that it gives us a minus 1. Not these exponents, 6, 16, whatever that we have there. So can this be simplified in a normal way? Remember, there are questions that you can actually be given. There are questions that you'll be given like this, just to simplify this. There can be a question like where you are given simplify 3j to the exponent of 6 minus j to the exponent of 6. Remember that you can be given a question like that. So they want you to first simplify this to its normal, to its simplest form. So how can we simplify this in simplest form? Okay, so you can just simplify this one aside. I'm just gonna try and have it here. Remember from j squared, so we're gonna simplify this. So remember j squared is minus 1. So you're gonna try to write j to the exponent of 6 in terms of j squared as j squared. So this was gonna be 3j to the exponent of 2. How can we obtain a 6 from j squared? How can we is it possible to obtain a 6. Yes, we have to raise this to the exponent of 3. Simply 6 divided by 2, that's a 3. We are just trying to rewrite this in terms of j squared. We move on, minus j to the exponent of 16. J to the exponent of 16 in terms of j squared. That is j squared, but raised to the exponent of what? So that we obtain 16. Simply divide 16 divided by 2. That's what? That's 8. Remember your exponents. Exponent, exponent, you multiply. 2 times 8, 16. 2 times 3, 6. So that you do not change the meaning of this person here. It must remain as it was. It's not supposed to change how it was given before. So this was going to give us 3 j squared, which is what? The purpose of us having this is because we want the j squared, which is minus 1. That's minus 1 to the exponent of 3. Minus j squared minus 1 to the exponent of 8. So this can be simplified. 3 times minus 1 to the exponent of 3, which is simply a minus 3 minus 1 to the exponent of 8. That's a positive 8. So that is going to be a positive 8, a negative. It is now raised to a positive exponent. Take note of what we have there. So it changes to be a positive, but already there is a negative there that we have, this one. So it's a negative affecting a positive. So it will remain as a negative. So this was going to be a negative 11. So on your simplification, it is very, very important. So take note here. Minus 1 is raised, or you can just use your calculator straightforward. Okay, let me bring the calculator here so that we can also see the simplification that can be straightforward. So this is 3, open bracket, minus 1, raised to the exponent of 3. Okay, then we're going to have a minus, open the bracket, minus 1 raised to the exponent of 8. Okay, so that was going to be a negative 4. Okay, guys, where am I getting this positive here? All right, there's something here. Okay, there's something here, guys. Negative 1. Where am I missing my calculation, guys? You see now this thing of... Hey, you see, guys, where am I getting... I'm sure it's right. 8. Guys, you see when they say to grow old is not fine. This is why 1 there. So this is negative 1. So it's now negative 1 and this will be a negative 4. Or it's just being tired. I don't know. So that's a negative 4. Okay. Now I'm wondering to say, guys, on my preparation, I'm seeing I'm having something else. On this one now, I'm having something else. Okay, so you must be careful, guys, there on your presentation. So negative 1 to the exponent of 8. Simply a positive 1 there. And you see, guys, when your mind is tired, even press that thing to say, this is, well, you're pressing something that is not exactly the one. All right, so that is, we've got a minus 4. Everything over what? The given denominator, 1 minus 2j. So this is where we are. So also verify, guys, where the calculator is needed. Verify, okay? Because your teachers always, sometimes they'll be tired. So verify as you are working, okay? Use your calculator. You're verifying. You are at this stage. You need to find or determine a rectangular form as we are given before. So we are simply back to the part that we had before of finding or determining the complex conjugate. Like I said, the denominator is not supposed to be having this j. So what is the conjugate? Introduce a negative, 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 that will be a positive. So that's going to be 1 plus 2j, everything over 1 plus 2j. So this is where we are. We can expand here. Minus 4 multiplies the 1. Minus 4 multiplies the 2j. Remember expansion. Minus 4 times 1. Minus 4. Minus 4 times 2j, which is going to be minus 8. Okay, that will be minus 8j. Everything over what? What we are seeing is we are back again to that part of a complex number multiplying its complex conjugate. And I said, whenever you see this condition, z, a normal complex number multiplied to its conjugate is simply a squared plus b squared. So you simply take, what is your a? That is 1. What is your b? That is 2. So you've got 1 representing a, then b represented by 2. So with this, it's going to be 1 squared plus 2 squared. Just like that. So you can leave it straightforward. So this can be written as 1 squared plus 2 squared. Just like that. So meaning to say, we can simplify this into minus 4 minus 8j over what? 1 squared plus 2 squared, that is going to be a 5. And separating this to have a real term on its own, the imaginary part on its own, that is going to be minus 4 over 5 minus 8 over 5j. Just like that. So this is what we're going to have at the end. So that's it, guys. Let's continue to work out our questions. Do revise as many calculations as you can. That can be very, very useful. All right, on another part, which is 2.2, you are now given to determine the value of x and y using Cramer's rule. Okay, there we are given 2 equations, and we are supposed to apply the Cramer's rule to solve these 2 equations. That's 2.2. So the first equation we were given as 2x plus 3y is equal to 4. Another equation, it was given as 4x minus 2y, which is equal to 12. So that's first and second one. And as you can see, these 2 equations, they're already in a normal format of our Cramer's, where variables on their own and the constants on their own. So we do understand that we can determine the value of x from the determinant that we are going to have with respect to x over the determinant of the constants, which you can obtain from the constants. The y can be determined from the determinant with respect to y over the determinant of that of the constants. So the question is, how am I going to have the determinant with respect to x? This is the determinant that you're going to obtain when you close the x part here and substitute it with the constants. So meaning to say, in place of x, instead of writing 2, 4, we are going to substitute the constants. So that will be 4, 12. The part of y remains as it is. So this is 3, this is minus 2. You can have your determinant. You move on to that of y. This time what we're going to do, close the part of y. Substitute with the constants. So meaning to say, the part of x is not affected, this one. We're going to take as it is 2, 4. But once you move on to this part of y, because it's y that you're focusing with, you substitute that with the constants, 4 and 12. So that will be 4, 12. The determinant with respect to the constants in that case, meaning to say there is nothing to be substituted because you are working with the constants. So you take as it is on the left-hand side of your equation, as it is. So you're going to take the 2, 4 as it is 2, 4, 3, and minus 2. 3 minus 2 as it is. So you can determine the determinants of these. Remember, the product of what you have in this major diagonal minus what you have in that minor diagonal. So meaning to say for x, you're going to have the product of 4 and minus 2 minus 3 and 12. 3 times 12. So that was going to be the determinant with respect to x. Okay, which is minus 8, minus 36, which is going to be minus 44, something like that. But for y, you do the same thing. Okay, what is in the major minus what is in the minor. 2 and what? 12. 2 times 12 minus 4 and 4. So that is going to be 24 minus 16, something like that, which is 8. For the constants, the same thing again. In the major diagonal, what is that you have? The 2 and minus 2, the 4 and 3. So that's 2 times minus 2 minus 3 and 4. 3 times 4. So this will be minus 4, minus 12. Something like that. Minus 4, which is minus 16. So that's the determinant of the constants. So with this, we can determine the values that you asked there for x and that for y. So therefore, x is equal to what? The determinant with respect to x over that of the constants. What is that for x? Minus 44 over that of the constants, which is minus 16. And y is going to be what? That of y over the constant. And what is it for y? That is 8. And for the constants, minus 16. So this was going to give us the values of x and y, the one that we want. So minus 44 divided by negative 16 was going to be 2,75. And on the other hand, the y is going to be negative 1 over 2, which is simply negative 0,5. So you have solved your equation using the Kramers. So if you've got time, you're in exam, you've managed to finish, you can even prove this with your normal methods, those substitution, elimination that you're used to. You can even prove that because the same values that you're supposed to have with any other method. This is a simultaneous equation. So let's work out as many questions as we can. Then on the other part on 2.3, it was determine the value of expanding along the first column, okay? They were supposed to say determine the value by in this case. Because if you say of, guys, it's going to be by the expanding along the first column. So what are we supposed to determine? What is the presentation of these lines here? This presentation, they mean determinant, this one, these lines here, the one that you see. So it's determinant of. You are supposed to determine, to evaluate the determinant of this that you're given, the determinant. It was a matrix that you're given and you need to find its determinant. So they can say determine like what you're just having on that part. 2, 3, 4, 1. You were finding the determinant of a 2 by 2. That one is a determinant of a 3 by 3. So they want you to have the determinant straight. So how do you find the determinant, guys? Remember, you are told where to apply. Expanding along the first column. Which one is our first column? This one. This is our first column. That's a column. The row is this one. That's a row. These are rows. So if they say the first row, you're going to use this one. But they need first column. Why is it important? Because we do understand that the signs, remember the determinant concept when you're presenting the signs, it's plus, minus, 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 a plus, minus, and a plus. So in the first column, the signs that we have, it's plus, minus, and a plus. These are the signs that we are going to use in the first column, a plus, a minus, and a plus. Okay, so let's expand and see what you're going to have. So the determinant of this whole part that we are seeing here is going to be 2. So it's plus 2. Okay, plus 2. The sign affects now, plus 2. So you're going to have plus 2. The determinant with respect to that, when you close where this 2 is, you close the column and you also close the row. This where 2 is. What are you going to remain with? This is what you're going to remain with, this one. That is the one that you're going to write here. Okay, so as we saw, guys, we are going to remain with -1, -3, -2, -5. You move on to another one, 5. It is affected by what? A minus. So it's -5. So that's -5. The determinant that we're going to have when we close where the 5 is, the column where the 5 is, and the row where the 5 is. So if you close this row and this column where 5 is, what are you remaining? 3, 4, -2, -5. This is what you're going to write. 3 in that order. 3, 4, -2, -5. Okay? So that's going to be 3, 4, -2, -5. The next one, it's a plus, but it's having a minus. 4 is having a minus. So it was supposed to be plus -4 is a minus. Then the determinant of, you close where 4 is, the column, and the row where 4 is, like this. So what are you remaining with? You are remaining with 3, 4, -1, -3. This is what you're remaining with. So with this, we can determine our determinant, guys, as you are considering expanding along the first column. So what were we going to have? You do the same calculations, guys, of your determinants as we're having there. Remember your determinants, you multiply the major diagonal, you multiply this, and you subtract this one. So it was going to be -1 times -5, which is 5, minus -3 times -2, which is a +6. Okay? -5 into, you do the same 3 and -5, that is -15. Minus 4 times -2, which is -8. So guys, a minus and a minus will give us what? It will give us a plus there. Okay? Then we move on. Plus and minus, that's a -4 into 3 times -3, that's -9, minus 4 times -1. Multiply this, so that will be -4. So as we can see here that a minus and a minus, that will be a plus. So we can simplify this, guys. 2 into what? 5 minus 6, that's -1. -5 into -15 plus 8. So that will give us a -7 there. -4 into, that will be -9 plus 4, which is -5. Okay, that will be a -5 there. Then you can expand using a calculator straightforward. That was going to give us a +53. So that is the whole determinant that we are having there. Okay, so let us just work out as many questions as we can. That will be 20 there. This one will be 35, and this one will be 2. So we have got, in this case here, okay, guys, where am I getting this 20? Let's work it out again with our calculator there. So that's why I say, guys, also verify as you are working out. Let's also verify this before we say that it's correct. You must verify that, guys, in your calculations. 2 into a -1, -5. That's a -5 into a -7 -4 into a -5, like this. Okay. So that was going to be 53, which is correct. Okay. So that's it, guys. 53. So it's good to verify because it's not always when your mind is fresh. So use your calculators in terms of your verification. So that was your question number 2, 20 marks. Question number 3, I'm gonna check this part. So it was actually, see, it was just 2 pages of this case. It was, all right. Okay, no problem. Let's just quickly see what we have so that we can be able to finish up our revision in this case. So if we check question 3, we're going to see that we've got our trigonometry, and 3.1, you're asked to solve for alpha. Okay, if 2 sine alpha times tan alpha minus tan alpha plus 2 sine alpha is equal to 1, and you're also given an interval to take from minus 90 to positive 90. Okay, let's see how we can solve this one. So given that's 3.1, so we are given this as 2 the sine of alpha times the tan of alpha minus the tan of alpha plus 2 sine alpha, like this, and this is equal to 1. So you will note that, okay, this is an equation that you're supposed to solve for alpha. And in this equation, we can see that there are terms separated 1, 2. These are terms that you're given. Second one, third one, and the fourth one. You're given 4 terms, 4 different terms. So there we can think of the factorization, but of grouping, where we can take the one to the other side, then we can try to factorize. So this is going to be 2 sine alpha, the tan of alpha, minus the tan of alpha, like this, plus 2 sine alpha. Then taking this one to the other side of the equation, that was going to be a negative 1, and this is equal to a 0. With our 4 terms, we're going to try to group them into 2. Are we having anything common from the first 2 terms? The tan of alpha is common there. So we can factor out the tan of alpha, which is common. Tan of alpha here, and also the tan of alpha here. So to factor out, that's removing that outside of this expression that you're given. So means if we take out the tan of alpha, we have a bracket remaining with what? 2 sine alpha. What are we remaining if we remove it here? You're going to remain with a negative 1. On the remaining 2 terms, is there anything common that you're going to factor out so that this here will be the same as what we have? And as you can see, it's exactly the same. So what can we factor out so that it will remain as it is? You factor out a positive 1 so that it will remain as it is. Remember, factoring out a positive 1 does not affect anything. So that is going to be 2 sine of alpha minus 1, which is equal to 0. With this, you have factorized, you have 2 brackets which are common, which are exactly the same. This bracket and this bracket. Factor it out. So 2 sine alpha minus 1, what are you going to remain with if you remove, just like what we had, you remove this, you remain with tan alpha. It's another bracket. You do the same thing, you remove this bracket, what you remain with? A positive 1. So this is equal to a 0. With this, guys, we can solve the 2 brackets using the 0 concept. Remember, the product of 2 terms to be equal to 0. It's either A is a 0 or B is equal to 0. So with that concept, we can equate this to be equal to 0 or the other bracket to be equal to 0. That's 2 sine of alpha minus 1 is equal to 0, or the tan of alpha plus 1 must be equal to 0. So let's solve for alpha. Now take the negative 1 there, becomes a positive. So it's going to be sine alpha is equal to what? A positive, you divide by 2. So that's 1 over 2. You do the same thing on the tan of alpha. The 1 on the other side, it gives us a negative 1. So this is where you are. Let's say you were just given a question. Let's say a question was just solve this or solve alpha there. How were you going to solve these two? Given the interval that our alpha is to be taken from -90 to +90. How were you going to solve? Guys, remember idea of the reference angle. Our alpha is to be taken to be greater than or equal to -90 degrees, or less than or equal to 90 degrees. This is our presentation. So remember the reference angle concept. We're going to determine the reference angle. Then we opt for the quadrants that we are going to have these as negative or as positive values. Okay, so let's consider the reference angle for the first one. The reference angle is going to be arc sine. This is sine, so it's going to be arc sine of 1/2, which is going to be 30 degrees. So the question is, where are we going to obtain 30 degrees? I mean, a half, which is a positive. From -90 to +90 from our quadrants. Remember, the cast. In which quadrant are we having sine being positive? In which quadrant? Sine being positive. In the first, in the second. In this quadrant, it's negative. In this quadrant, it's negative. So you cannot consider that. So when you say negative angles are not going to be taken, because if you take a negative angle, sine of -30 degrees, it will give you a -0.5, not a positive 0.5. So it's not to be taken. So you're going to take your answer in the first quadrant, where in the first quadrant, alpha, the exact angle that we want, is equal to the reference angle. In the second quadrant, it cannot be taken because it's 180 minus the reference angle, which is an obtuse angle. If you subtract this from 180, that's 180 minus 30 degrees. It was going to be 150. So when you say it's out of the interval, remember, we are limited to 90 degrees. So this quadrant only, we're not going to consider this quadrant because it's more than 90 degrees. So when you say our alpha was going to be 30 degrees. So for the first one, alpha will be equal to 30 degrees, according to the quadrant that we are dealing with. Okay, let's check for tan. The tan that we are given, it's a -1. So the question is, what is our reference angle? Remember the reference angle? Ignore the sign that you're given a negative here. Let's find arctan of 1, which is what? 45 degrees. The negative, you use it now to tell the quadrant where the tan is a negative from the cast diagram. Where is it that tan is a negative? Tan is a positive in this quadrant, and in the first quadrant, that's where tan is positive. So it means it will be negative where? In the quadrant where sine is and where cos is. But of these two quadrants that we are going to have our answers, these two quadrants, which one are we going to use? Because we are given an interval from -90 to 90. So we cannot expect to have an angle that is more than 90 degrees. So this quadrant is totally out. It's very true that tan here it's a negative, but we cannot take this because our answer will be more than 90 degrees. You get 180 minus 45, which is 135 degrees. So it's not to be taken. What about this quadrant? These angles, we're talking of 0 degrees. Going this side, these are negative angles up to -90 degrees. So we can take this quadrant. It is within the -90 degrees. So we're going to take our answer in this quadrant, not this one. So therefore, what is going to be our alpha? how do you take the angle in the fourth quadrant given the reference angle? I say that the exact angle that you want to calculate will be 360 degrees minus what? Minus the reference angle that you're given. That's the first angle. Or the exact angle that you want, which is alpha, is equal to the, when you're considering negative angles, remember, going this side, these are negative angles, it will be equal to minus the reference angle that you are given. If alpha is this, alpha is the same as minus. There are two which are the same thing. So in this case, we're not going to use 360 minus reference angle because it will be more than, it will be out of the interval. We are going to take this one where alpha is equal to what? To the minus of the reference angle. So therefore, from this, we can conclude that our alpha from this side was going to be equal to minus the reference angle, which is what? 45 degrees. So it was going to be minus 45 degrees. For us to obtain a negative one, it must be tan minus 45. So these were the answers that we're going to have in the final. We can say, okay, no problem. Let's just write our alpha. It's going to be minus 45 degrees, or from this other calculation, it was what? 30 degrees. So these are the angles that are representing alpha that satisfies the condition of alpha that we are given, where this will be a negative one. Tan, it's negative. There, sine was positive. You consider the quadrant where sine is positive, but also limited to the angle. So don't just say, okay, this is the quadrant where sine is, it's true, but the angle, the interval is limiting you to say, whatever angle that you're going to choose is limited within these. So you're not going to take any answer that you think of. So that is the condition there. Let us see other part of our question. So I think 6 marks, it was enough. It was fine. Let us see 3.2. Simplify the following expression. You are given that's 3.2. You were given the cos of 2p, everything over the cos of p minus the sine of p. Remember your double angle identities, that the cosine of 2a can be written in many ways, guys. If considering the cos, it can be given as 2 cos squared. This can be given as 2 cos squared a minus 1. Can be given as 1 minus 2 sine squared a, which was actually taken, all these were taken from cos squared a minus sine squared a, remember. So according to our question, we can see that there's a cos p minus sine p in the denominator. So we can opt for the first one, that is a cos and a minus sine, because there we know that a difference of two squares can emerge. So we are going to take the first one instead of us taking the second one or the third one. We're going to consider this one. So this is p, not a. So it is going to be cos squared p minus sine squared p. Just like here, cos squared a minus sine squared a, from cos to a. Everything over what? Cos of p minus the sine of p, which is a difference of two squares. If we do understand that a squared minus b squared is equal to a minus b into a plus b as a difference of two squares, that's the same thing. That's a cos squared, which is same as a. So the square root of this, that was going to be cos p minus the sine of p. Another bracket to add, the cosine of p plus the sine of p. Everything over what? The cos of p minus the sine of p. This is where you are, where the two brackets here are the same. This cos of p minus sine p and this cos p minus sine p are the same. This is just a bracket. So you are remaining with what? This is a 1. So divided to this, this cos p plus sine p divided by 1 is just going to remain as cos p plus the sine of p. You have simplified. So the question was to simplify, evaluate. is. Okay, just like that. So let's check 3.3. If the sine of alpha is 4/5 and sine of beta is 5/13, calculate without a calculator the value of sine of alpha minus beta. Remember that the sine of alpha minus beta is given, also given this from our formula sheet, which is equivalent to sine of alpha, the cos of beta, minus the cos of alpha, the sine of beta. So if we are to consider this is the sine of beta. If we are to consider the sine of alpha is given, this is what we have here. Sine of alpha is given. The sine of beta is given. So you're limited on this formula because you do not have cos alpha and you do not have cos beta. So that's where these will play a role for us to determine the cos of beta and the cos of alpha. So we must be told what these angles represent or which quadrant are they found in. So that's why we are told here that where these alpha and beta are both acute angles, they are both acute. And as we understand our quadrants, this is 0, this is 90 degrees, this is 180. An acute angle is an angle in between 0 and what? 90 degrees. So they are simply telling you that where alpha and beta are both in the first quadrant, they can also give it like that, in the first quadrant. They can give you like that. So that on your presentation, you do understand where to present these. If they are both in the first quadrant, let us start with the first one. The sine of alpha from our SOHCAHTOA concept, we do understand that the sine of alpha is opposite over the hypotenuse. So if it is in the first quadrant, we're going to have our triangle like this in the first quadrant, where we can say, okay, this is our alpha. So according to this alpha, our opposite is this side, which is 4. Hypotenuse, which is this side, which is what? 5. So definitely you're going to use your Pythagoras theorem to calculate the third side, which was going to give you a 3. You can even see the 3, 4, 5 method, or you can use the Pythagoras theorem. Remember that h squared is equal to a squared plus b squared. Or you can write it in terms of x and y. That is r squared is equal to x squared plus y squared, where r is the hypotenuse that you are given. 5 squared is equal to x. Remember, it was not given. So it will be x squared plus y squared, which is 4 squared. You solve this. 25, this is 16. You take it this side, it will be minus 16 equal to x squared. 25 minus 16, that's 9, is equal to x squared, the square root. So 3 is equal to x. So that is the one that you have, and it's a positive. Remember, so it's supposed to be plus or minus. But this side is supposed to be a positive from your Pythagoras theorem. So what's the purpose of the triangle and the quadrant? So that we can determine the cos of alpha as it is going to be needed. So from this diagram, the cos of alpha from adjacent over the hypotenuse was going to be what? This is our adjacent. So adjacent, that's a positive 3 over the hypotenuse, which is a 5. So the hypotenuse is always positive. No matter the side, the quadrant, whether it was this side, hypotenuse always positive. So it only affects this y value and the x value. From the sine of beta, we do the same thing. It's another triangle you have there. So you're going to consider another part where the sine of beta is to be used. So let's say this is angle beta. Opposite over hypotenuse, we saw that. So this is our opposite, which is 5. The hypotenuse this side, which is what? 18. So using your Pythagoras theorem, just like the previous case, you're going to calculate this side and obtain a 12. With this, you now have the cos of what? The cos of beta. Adjacent over hypotenuse, adjacent, which is 12, over the hypotenuse, which is 18. So that was the importance of this diagram to determine these missing trig that we have there, I mean, or the cos of the cos of alpha and the cos of beta there. So with this, we can substitute. So meaning say the sine of alpha minus beta can be written as sine alpha, already given from our information, 4/5 times the cos of beta. We calculated 12/18. So that's 12/18 minus the cos of alpha. We calculated this one, 3/5. So you're going to take the cos of alpha, 3/5 times the sine of beta already given, which is 5/18. So that was what you're supposed to have. So you can simplify. So like I said, if you're to consider this not to have a challenge, just because you're going to see that the denominators there, they're actually the same. This is 5 and 13, 5 and 13. So for you to maintain those denominators, multiply the numerators together, denominators together separately. So 4 times 12, which is going to give us 48. So you multiply these together. Okay, that will be 48 over what? 5 times this 13, which is 65, minus 3 times 5, which is 15, over what? 5 times 13, which is again 65. So that if the denominators are being maintained, as we can see there, that the denominators are the same, we can simply subtract the numerators together. So this is simply going to be 48 minus 15, everything over what? 65. That is what I'm trying to say. So that's if you subtract, that is going to be 33/65. So simplifying 33/65 is, are we having anything common there? We do not have. So it will just remain like that. So that was going to be our sine alpha minus beta from that. You are given a certain ratio. Use that to draw or to represent a triangle in the quadrant that it is satisfied. This condition, both are being satisfied in the first quadrant, where both angles are acute. So they can give you, in terms of interval, they are simply saying where alpha is what? Greater than or equal to 0 degrees, less than or equal to 90 degrees. And beta is also, because an acute angle, where beta is also greater than or equal to 0 degrees or less than or equal to 90 degrees. They can give it this way. They can tell you exactly where it is. They can tell you in terms of angles, like the type of the angle. So you must be able to locate the quadrant from any statement that you're given. 3.4, express the cos of 2x in terms of sine only. So our answer is supposed to carry a sine only. Okay, remember cos 2x, there's an identity which actually carries a sine only, which is 1 minus 2 sine squared x. So they want you to have this, like, how are you going to obtain this? From the normal identity that the cos 2x is equivalent to, it is equivalent to cos squared x minus sine squared x. But this cos squared x, we do understand that from our Pythagorean identities, cos squared x plus sine squared x is equivalent to 1, where we can make the cos squared the subject because it's the one that we need here. So it means cos squared of x is equal to, transpose this, that will be 1 minus sine squared x. So meaning, where there's a cos squared, I'm going to write it as 1 minus sine squared, wherever I am having a cos squared. So this will be 1 minus sine squared x, subtracting a sine squared x already on the formula. So that is what we're going to have. So this is simply minus 1 minus 1. So minus 1, that's minus 2 sine squared x. So as you can see, that's what we had. You are already having these identities, but they want you to rewrite them like from where they can be taken from another identity to that. On 3.5, simplify. So that is, we are given to simplify the sec of x minus the tan of x. This whole part is going to be into the bracket of the sec of x plus the tan of x divided to what? To the tan of x. So the question is, what exactly are we going to have? Like, what are we having here? There's a difference of two squares that is just hidden here. A squared minus b squared is equal to a minus b into the bracket of a plus b. A difference of two squares. The difference of two squares. So if it is like that, that you're applying the difference of two squares, a minus b, a plus b, was taken from a squared minus b squared. This is our a, this is our b, this is our a, this is our b. So what is a squared? It simply means sec squared. B squared, tan squared. So we can have it as a reverse. So this was taken from sec squared x minus this was taken from tan squared x. This is what we had, and we rewrote it like that. Everything over what? The tan of x, which here we have an identity equivalent to that. Remember that sec squared minus tan squared is equivalent to what? To 1. Okay, where is it taken from? Remember, guys, this. Remember that we can have our identities from the sec squared, sec squared x plus 1. Okay, we can write it in terms of tan actually. Let me have it here. Remember this one, cos squared x plus sine squared of x, which is equal to 1. From there, we can have the one that we have got a sec, which is given as 1 plus tan squared of x, which is equal to a sec squared of x. If it was for a cosec, 1 plus a cot would be a cosec. So here is 1 plus tan squared, which gives us sec squared. From our normal presentation, this is what we understand. What we need is this sec squared minus tan squared. What does it present? What happened? They just took this to the other side like this. If you take it to the other side, as you can see, it's a positive here. You take it there, what's going to happen? It becomes a minus on this other side. So it's going to be a 1 remaining. But now, on this side, we are now having sec squared, and we have taken the tan that side. So it will be a minus tan squared. So they are simply taking from a normal identity that you are used to. They want you to manipulate that identity to match what you're given there. So as we can see, this presentation can be written as 1. So this is 1 over tan of x. And what is 1 over tan? Remember, 1 over tan, it gives us a cot. So this is cot x. So this was going to be simplified up to a cot x. So that's how your questions can be given as 4 marks. On question number 4, you are now on the derivatives. Differentiate from first principles. And that was, okay, let's see. Oh, they just wrote the marks. I'm now surprised, guys, to say, where are the marks now? I'm now trying to, zoom in as much as I can. Okay, there is 5 times 5, which means each is 5 marks, which is fine. So differentiate from the first principles, y is equal to minus x cubed on 4.1. So this is what we had. Y is equal to minus x cubed. Remember your first principles that the derivative of y with respect to x can be calculated from the limit where h is to be approaching to 0, and we've got f of x plus h minus f of x, everything over h. This is the formula that we actually do understand. Okay, what if I just expand this? Because I do understand that on this formula, I will need this. F of x is already there. This is the y that we are seeing here. This is your f of x. Remember that. So your f of x plus h means what? Your f of x plus h means where there is x, put x plus h there. So you put x, so it's going to be minus, you put x plus h. So it's going to be x plus h, but raised to the exponent of what? 3. Raised to the exponent of 3. So you can simplify it before the substitutions. So let's simplify this and see. It was going to be f of x plus h is equal to what? You can expand. Remember, you are used to the expansion of x plus h squared. You are used to this, that this one is going to give us x squared plus 2xh plus h squared. You are used to this from the a plus b squared concept. Remember, a plus b squared gives us what? A squared plus 2ab plus b squared. Or you can expand your brackets in the normal way. But if you are used to this, therefore, rewrite this x plus h to the exponent of 3 in terms of a squared, in terms of it raised to the power of 2, meaning to say we can have it as minus x plus h into x plus h squared. Remember, if you're multiplying brackets like this, you can simply add the exponent because they are the same. 1 plus 2, which is 3. We haven't changed anything here. We haven't changed anything. Only that we want that part which is easier for us to expand, the one that we are used to. So now you can just simply substitute minus x plus h. Okay, in this case, again, you can simply do this because you want to expand. You can also do this before. You can simply expand this bracket by a negative. The negative is going to affect everything. But you can even use the first bracket. Negative multiplies this x. So it will be negative x, negative multiplies h. So it will be negative h like this. Then you take this part of x plus h squared, this one that is remaining. What is it? This is the one that you have here. So you're going to take as it is, which is x squared plus 2xh. Okay, plus 2xh plus h squared like this. So with these, we can now expand the normal way that we are used to. This minus x multiplies everything in the second bracket. Everything minus x. So it's times x squared, which is minus x cubed. Minus x multiplies this part. So what are you going to have? We are going to have minus, that's a positive, so it's going to be minus 2x squared h, x and x squared. Minus x multiplies this part, so that is going to be minus x h squared. So minus x is multiplied everything in this bracket. You do the same thing for what is remaining, the minus h. It multiplies everything in this bracket again. So let's multiply. Minus h times x squared. So it was supposed to be minus h x squared. But take note, they were writing in terms of x followed by h. So do the same thing. Start with x. So it will be minus x squared h. Okay? You do the same thing. So here, it multiplied here. It also multiplies this part. So what are you going to have there? Minus and a plus. That's minus. So it's going to be 2x h and h squared. You do the same, minus h and the plus h, which is minus h to the exponent of 3. So with this, we can collect our like terms. So we're going to collect the like terms in this case, meaning to say the part of x cubed is just on its own. But this part of h where we have got minus 2x squared h minus x squared h is this part of h there. And this part of h squared where we've got minus x h squared minus 2x h squared. If you consider this, these are like terms there. So meaning to say the first one, the x cubed, this one, there's no effect, just going to remain as it is. Then on the remaining part, we say there's this part of h here. So there is minus 2x squared, and there is minus x squared. So minus 2, minus 1, that's minus 3. So it is going to be minus 3 x squared h. Okay, we move on to this part of h squared. There's h squared and h squared. So this is negative 1 x. This is negative 2x. So negative 1x, negative 2x, that is negative 3x, but there is h squared. Those are the like terms. And the last one is the minus h cubed. There's no effect, just on its own, this one. It does not have any corresponding like term. So this was your f of x plus h. This is what we're going to have, which is fine for you to take that and substitute into this formula f of x plus h minus divide. Or you can even simplify. Guys, I said you can even simplify. Guys, you see the here. Your formula is stating that what you need is what? F of x plus h minus what? F of x. Our f of x is this. So let's find it. Let's find that x because now we have, this is our f of x plus h, this one. So let's find f of x plus h minus f of x because it's already there on our formula. So f of x plus h minus f of x simply means on this f of x plus h that we are seeing here, you're going to subtract f of x, which is minus x cubed. Okay, so let's subtract. Let's see. You can even simplify that aside. Minus x cubed minus 3x squared h minus 3h x h squared minus h cubed. So you're going to subtract the f of x, which is minus x cubed. Remember, f of x was what? X cubed. This one. It's your f of x. So the whole of this part here, up to here, the whole of this part up to this point here, it represents our f of x plus h minus f of x. So what are you going to have at the end? So it was going to be a plus here. Minus and minus, that's a plus. So minus x cubed and plus x cubed cancels. You remain with minus 3x squared h minus 3x h squared minus h cubed. So this was representing f of x plus h minus f of x. This is what we have now. So let's go back to our formula and see what we have determined. This is what we have determined. We have determined this. What is it that is left? To divide by what? By h. So this is what we're going to take. On our formula, there is f of x plus h minus f of x over h. We just take that piece on its own. So you're going to take this, we divide it to h. So meaning say to divide this by h, you're going to divide each and every term. Minus, because it was supposed to be like this, guys. It was supposed to be over h. As we can see, there is h here, there is h here, there is h here. So you divide each and every term by this h. It was supposed to be like that. But this is how you present it. Minus 3x squared h over h. Minus 3x h squared over h. Minus h cubed over h. So this is what you're going to have. The h and the h cancels. You're going to have minus 3x squared. Minus this into this, we're going to have minus 3xh. We're going to have 1h remaining. minus h into this one. There are 2. How many are going to remain? 2 of them, h squared. This one, which are 3. So you're going to remain with 2. So this is what your f of x plus h minus f of x over h is representing this. This is what we have. So we are going to take it now into our formula. Let us take this as it is here on this formula, as it is. Remember your formula here, as it is. So on our formula, therefore, the derivative of y with respect to x is equal to the limit as h is going to approach to 0 of what? This whole part, this one, we simplified it as it is here. We have got the resultant of it, this one. We simplified it separately. This is the one that we are simplifying. All this, it was to obtain that, this one. As it is here, we're going to substitute as it is. So let us see what we're going to have. So as we can see there, it was minus 3x squared minus 3xh minus h squared. This is what we got. But we are saying h is supposed to be limited to a 0, where h part of h is supposed to be a 0. So therefore, the derivative of y with respect to x, we're just going to remain with this part because we do not have h there. So it is going to be minus 3x squared. We can substitute each and every part where h is given, each and every part where h is given. But where we do not have h, there's no effect. So this was just going to remain as what? Minus 3 because these are zeros that are remaining there. So that was the idea of this question. You can work it aside or you can work it here on the formula you're substituting. It's up to you. So this one, it serves you to say, you just know, okay, these are calculations on their own. You just move on with your calculation. You find the difference. You find f of x minus that difference. You divide by h. Then you just substitute there. All right, let's consider another question, which is on question 4.2. Given y is equal to this, calculate with aid of differentiation the coordinates of the turning points. So how do we obtain the coordinates of the turning point? Okay, that's another part of our question that you're given. How do we determine the coordinates of the turning point? All right, that's 4.2. So you're given that y is equal to x cubed minus 12x squared plus 36x. Remember, at the turning points, the derivative of y with respect to x is supposed to be equal to 0. First derivative of y with respect to x is supposed to be equal to 0. So let's determine the derivative. Derivative of y with respect to x. We're going to drop the exponent. That's 3x squared. Remember, you drop the exponent, then you subtract 1. You drop the exponent, you subtract 1. So you're going to be minus 12 times 2, which is minus 24, x to the exponent of, you subtract 1, that is going to be a 1. So it's just going to be like that. This is 36x, a linear, so you're just going to take 36 as it is in that case. This is our derivative of y with respect to x, which is supposed to give us what? A 0. So that's with an equation. 3x squared minus 24x plus 36, it must be equal to 0. So we can solve this equation. We can even reduce this equation. As you can see, 3 is common here, so you can divide by 3, by 3, by 3. Each and every term can be divided by 3. So 3 and 3 was going to cancel, and that was going to be x squared minus 24 divided by 3, that's minus 8. So it's going to be minus 8x, 36 and 3, that is going to be plus 12, which is equal to a 0. Solve this equation with any means that you can. Is it by the factorization? Is it by the quadratic formula? Solve for x. So in this case, I'm going to apply the factorization. As you can see there, we've got terms that can be used common. A 1 because of this one that we have there, just going to have two brackets, remember, which is x here and x. Because of this one, x times x is what? X squared. So just concentrate or focus with the 12, which is the constant. What are the products? So you need the products, two terms. You multiply these two terms, you must obtain a 12. Products that will give us a 12, but added, they must give us a -8, this one. You take two numbers, you multiply them, 6 and 2, you get a 12. 6 times, you get a 12. But if you add 6 plus 2, it's what? It's 8. 6 plus 2 is +8, not -8. So how can we obtain a -8 by adding? This must be negative, this must be negative. -2, -6 and -2, that's a +12 if you multiply. If you add these two, you get a -8. So these are the numbers that we need, which will satisfy this to be a negative there. So that's a -6 and a -2 here. Equal to 0, one of these brackets. So that's x minus 6 is equal to 0, or x minus 2 is equal to 0. So what is the value of x? That's a +6. Or what is the value of x on this other side? A +2. With these values, we can now substitute into the original equation to determine the y values at the turning points now, because we need the exact turning points. What will be the exact turning points? So into the equation of y is equal to x cubed minus 12x squared plus 36x, you're going to substitute when x is 2. So in place of x, 2 to the exponent of 3 minus 12, 2 to the exponent of 2 plus 36. In place of x, you substitute a 2. That was going to give you a 32. So meaning to say, we have a turning point. You can just call it TP1, where x is 2. At that point, y is 32. And the second one, you do the same thing for 6 in place of x. You're going to substitute a 6. And that was going to give us a 0. So the second turning point, when this is a 6, it was going to be a 0. So you can substitute the points, all right? Let us also verify, like I said, guys, when it is of calculations, also verify with your calculator. So in place of x, we say the first one, it was going to be 2 to the exponent of 3 minus 12 into 2. Like this, that's minus 12 into, open bracket, that's 2 to the exponent of a 2. All right, guys, let's just hope we're going to win 2 to the exponent of 2 plus 36 into 2. Okay, this was going to be +32. Then now we just substitute here a 6. Just put a 6 here. Also put a 6 there. And a 6 here. This was going to be a 0, as you can see. So these are the values that we're going to have at the end, representing our turning points. Just like that. So at the turning point, the first derivative is supposed to be equal to what? Is supposed to be equal to 0. The first derivative. So I don't think we're gonna need this function, so we can just remove this. Okay. 4.3, given that y is equal to 5, the square root of ln x, differentiate with the add of a function or chain rule. 4.3. Okay, let's see what we are given there. You are asked to use or to apply the chain rule, which is the function of a function, to differentiate y is equal to 5 ln 5 as the square root of ln x, like this. How is this possible? Function of a function. The moment you're given that chain rule, what is that you think of? You must think of having this derivative of y with respect to x from the derivative of y with respect to u times the derivative of u with respect to x. As we can see, there must be another function to be introduced in this. The square root is same as what? 5 ln of x raised to the exponent of a half. So we can take off the part that is complicated here, that is being raised to the exponent of a half as our u, so that the derivative of u can be determined. So we can let our u to be equal to what? The ln of x. We can let our u to be the ln of x. If we have u as the ln of x, what does it mean? It means y now can be rewritten as what? Y can now be rewritten as 5 in place of the ln, you're going to put the u. So it's now u to the exponent of what? Of a half. Okay, there's a 5 there. Okay, don't forget the 5. So it's 5u to the exponent of a half. That's what we have there. Once you let, it's now another. That's why we need that of y with respect to u. From this one, we can determine that derivative of y with respect to u. Simply drop the exponent. A half times a 5, that's 5 over 2. U to the exponent of what? You subtract a 1. So that is going to give us a minus half. Remember, a negative exponent, this one, it means 1 over. So it's going to be 1 over u to the exponent of a half. But already there's a 5 over 2 that is there here. So meaning to say this was going to give us 5 over 2. What does u to the exponent of a half mean? To the exponent of a half was taken from the square root. So it means the square root of u. It means the square root of u. So you can leave it like that. This is the derivative of y with respect to what? To u. On this other end, remember you will need that of u with respect from this u here. We need that of u with respect to x. So it follows that from this one, the derivative of u with respect to x was going to be what? Remember, it's ln. That is 1 over x. So that's it. We can determine here our derivative of y with respect to x. dy du, the derivative of y with respect to u, which is 5 over 2, the square root of u, times the derivative of u with respect to x, which is the 1 over x. So that's it. We can now multiply the numerator to the numerator. So the derivative of y with respect to x was going to be 5 times 1, which is 5 over 2 square root of u times, so it's going to be 2x square root of u. So you cannot leave our answer like this because this is written in terms of u, which is supposed to be in terms of x. So u is what? Remember we said u is the ln of x. So instead, we are going to have our answer as the derivative of y with respect to x is going to be 5 over what? That's 2x, the square root of where the u is. You substitute with what represents the u, which is the ln of what? The ln of x. So this is going to be the square root of the ln of x. Just like that. So this is our function of a function, chain rule. So you just need to work with typical exam questions to be revised so that you see how do they ask these questions and so on. On another part, they want you to differentiate this. How can we differentiate this whole part? Okay, that's 4.4. Let's see what we are given there. So we're asked to differentiate y is equal to the square root of x to the exponent of 3. Into the bracket, then we've got x to the exponent of minus 2 plus x raised to the exponent of 2 like this. So the question is, how are we going to differentiate with respect to x? Y with respect to x? Let's consider expansion of the brackets here. Expand the brackets. One bracket to another one. The square root of x to the exponent of 3. What does it mean? Remember, x, when it is written as under the square root like this, maybe we're given the square root of x. This is x to the exponent of a half. So what about the square root of x to the exponent of 3? If there's an exponent here, there, it's representing like a 1 over this number here. So it's going to be 3 over the number inside. We saw that the number there is what? The square root. It's already there. The number is already there, which is what? Which is 2. So it's not going to be 1 over 2, but it will be 3 over 2. So this here can be written as x to the exponent of 3 over 2 into this bracket, which can be expanded. We can expand this. So what are we going to have? Remember, guys, this does not change. It's raised to the power of 2. Remember, I say that a plus b squared is the same as we've got a squared plus 2ab plus b squared. So our a, this is our b. So it's supposed to be a squared, which is this number to the power of 2. So that's x minus 2 to the power of 2. What are you going to have? Power and the power. We multiply 2 times minus 2, which is what? Minus 4. We have what? The part of a squared. 2ab plus 2ab. So it's supposed to be plus 2 times a. What is our a? Our a, x to the exponent of minus 2. Our b, what is our b? Our b is x. So if you multiply, what are you going to have? The bases are the same. Add the exponents. Minus 2 plus 1, which is minus 1. So this was going to be plus 2x to the exponent of minus 1. Minus 2 plus 1, which is minus 1. The last term squared, which is b. So this is b squared, which is x squared. You have expanded. Yes, you can open the brackets. I'm not saying it's wrong to open those brackets. You've got 2 brackets that you expand this bracket into another bracket. You could have done that. X to the exponent of minus 2 plus x into the other bracket of the same. You expand it normally, allowing the use of the laws of exponents, where the bases are the same and you're multiplying at the exponents. This is also going to happen here because you need to expand the brackets. Before we are not yet differentiating, we are still simplifying so that we can differentiate. Expand. Add exponents. So when you say this was going to be what? 3 over 2 minus 4. We add minus 4. That was going to be minus 5 over 2. Plus, you do the same thing. X and x there is you multiply. X and x, you add the exponents. 3 over 2 plus minus 2. It was going to be 2x to the exponent of minus half. The x and the x there, you add exponents. 3 over 2 plus 2, which was going to be 7 over 2. At this stage where we can see or have our y separated, we can determine now the derivative of y with respect to x. Drop the exponent, you subtract a 1, just like that. So that was going to be minus 5 over 2. X to the exponent, you subtract a 1 here. That was going to be negative 7 over 2. You drop the exponent here. That is 2 times minus half. That's minus 1. This one, there's a negative there. So it's going to be minus 1. X to the exponent of what? You subtract a 1. So it's going to be minus 3 over 2. So drop the exponent, subtract 1. Drop the exponent. There's a 1 here. So 1 times 7 over 2. That's 7 over 2. What are you going to do? Subtract a 1. That was going to be 5 over 2. You have differentiated each and every term. Each and every term. That is the condition there. All right, this was going to be 3 over 2 and a half. This is minus 1. Here was so like this was going to be a positive here, guys, okay? Seeing that, okay, let's just correct here. So this was going to be a positive here. The 3 over 2, you add to that 1. 3 over 2 plus minus 1. It was going to be a positive half. So that's a positive half here. Okay. So meaning to say, when you drop the exponent, it's going to be half times this, which is a positive 1. And you subtract a 1. So it was going to be a minus half. So it's going to be, let's correct this part also. It was going to be a minus half here. All right. So let's also try work hand in hand with our calculators as well. So that is what you're going to have on this derivative. Let's check another part. 4.5. Differentiate using the product rule. Using the product rule. Y is equal to ln squared x times e to the exponent of x. Okay, let's see. Let's see what we're given there. Y is equal to the ln squared of x times e to the exponent of x. And you're asked to use the product rule, where we do understand that the derivative of y with respect to x, if this represents u and this is our v, we are simply going to take u, first derivative of v, plus this time it will be the first derivative of u, v remains as it is. So our u in this case is this part, represented by the ln squared x. Remember, this is the same as the ln of x to the power of 2 like this. So how can we differentiate it? Is it possible? Yes, it's possible. So there's just substituting into the formula. We are done. So the derivative of y with respect to x is going to be what? U as it is. This is our u. So it's going to be ln squared x times the first derivative of what? Of v. The derivative of e, guys, is what? It's e. It remains as it is. So this is e to the exponent of x plus the first derivative of u. So u, need the derivative here. Remember, from your function of function, you can even do it by side, by looking into this. By side. You differentiate the outer part of this. That is going to be 2. You drop the exponent there. So it's going to be 2 ln of x. You subtract a 1 there. So it's going to be a 1. Then you differentiate the inner part. You differentiate when you're looking in the outer part. Now, inside the bracket, the ln of x is what? It's 1 over x. So meaning to say, this part that we are seeing here was going to be 2 over x ln x. This one, 2 over 1. So it's going to be 2 over x ln x. So we're going to obtain 2 over x, the ln of x, times v. V as it is, which is e to the exponent of x. That's it. We're done. You've differentiated each term. There's no need there for you to simplify anything. Just differentiate each and every part separately. Just make sure that each and every part is what is done separately. So that was it, guys, for 25 marks on our question 4. 25 marks, which is actually enough for us to have, guys, try to balance at least 20 out of 25 or something like that, so that you aim for a distinction. So if we are to consider our question number 5, you are given 5.1, that was to simplify the integral of cos squared minus sine squared x. This is if you're to consider from your identities. Remember, we talked of this identity of cos 2x. We saw that it was equivalent to cos squared x minus sine squared x, also equivalent to 2 cos squared x minus 1, also equivalent to 1 minus 2 sine squared of x, which we can see that there we are given cos squared minus sine squared, this one. So it is exactly representing cos 2x. So instead of us having it the way that it is presented there, that is difficult for us to integrate, we can simply take this as the integral of the cosine of 2x with respect to x. Remember, from your integrals, we can integrate this cos, considering that cos is going to change to a sign. Of course, it's going to be a sign as a positive, but you must divide by the number that we are seeing the 2 there. So this is going to be the sign of 2x, everything over 2, then plus the constant of integration. So that was what you're supposed to have done. On 5.2, you are supposed to integrate each and every term, like I said before. So remember that. So you're just going to try to evaluate each and every part properly. There we just needed, we can even integrate this, guys. This is straightforward. Let's just integrate and see what you're going to have. E to the exponent of 5x. Remember that E, whenever you're given this format of a to the exponent of a certain number, we're going to need the derivative of that. Okay, so you're going to need its derivative of e to the exponent of x. Okay, going to need its derivative. So it's going to be e to the exponent of 5x as it is divided to its derivative in that case. So we're going to need its derivative. You divide by that. So in this case, it is going to be a 5. And multiply to the ln of that base, which is e, and the ln of e is 1. So the derivative of this is your f of x, okay? So this one is your f of x. So its derivative is 5. The ln of e is 1. So this is just simply e to the exponent of what? Of 5x over 5. Okay, if you know this, guys, just write answer. Remember, understand this concept. Then we move on to another part. Okay, maybe we're just going to need this in our later presentation, but still it's fine. If you are to consider, that is exactly what we need here on this 3 pi. So we still need that same concept. So let us just say we have got a to the exponent of f of x, remember, like that. So this is what we have. So there we now have a constant, which is 3. Then we've got pi to the exponent of 3x. So 3 is a constant, just going to multiply the answer that we are going to have in this case, which is a to the exponent of this one as it is pi to the exponent of 3x over what? The first derivative of this 3x, which is 3, times the ln of a, which is the ln of a, that is our pi in this case. So this is going to be the ln of pi. So as we are to consider that these we're going to cancel, okay, these we're going to cancel the 3 here, and also the 3 that we are having. This was going to cancel. So meaning to say our answer was going to be plus pi to the exponent of 3x, everything over the ln of pi. So that is for the integral part that you are having. So you must divide by that part, which is the same part that you are having there on the 10 that we are also having here. On this 10, there is a minus 10 to the exponent of 2x. So that is going to be a negative. This as it is 10 to the exponent of 2x over what? The derivative of these 2x, which is 2. Then we've got the ln of 10. So meaning to say, in this case, we were going to have this as, okay, so that was going to be a minus 10 to the exponent of 2x, everything over 2, the ln of 10. So you're going to have it over the ln of 10. Then on this other part, we can integrate this, just rewrite, that is 1 over 2. Remember, the square root that we are seeing there represents to the exponent of a half. So you can take this, rewritten as 1 over 2, x to the exponent of half, write it on top there. It will carry a negative exponent like this. So now we can integrate. Remember, integral, the concept, you have to add 1 on the exponent when it is like this. So this is going to be 1 over 2 times x to the exponent. If you add a 1, that is going to be 1 over 2 over 1 over 2. So that is going to be 1 over 2 times 1 divided by 1 over 2, that's 2 times x to the exponent of a half, which is this going to cancel, and you remain with x to the exponent of a half. So this is plus x to the exponent of a half, which is same as the square root of x. Then integrate p with respect to x. That is going to give us px. Remember, p is a constant when it is like that. plus the constant of integration. You have integrated each and every term that you are given there. So that is what you're supposed to have for 6 marks. Was fine. Then 5.3, you're asked to integrate, evaluate this with the limits. That is 5 over x plus 6 with respect to x. So remember that we can integrate k over x to obtain k ln x. If it is like that here, if it is a over x, it's going to be a ln x. So there we are given a represented by 5. So we can integrate this. That is going to be 5, the ln of x. 6 is a constant. We saw that when working with a constant with respect to x, is going to be 6x. So this is going to be 6 times x. Then we can apply the limits, which is 3 and 1. So the upper limit minus the lower limit, what we're going to have in place of x, this was going to be 5. The ln of 3 plus, in place of x, you substitute a 3, that's 6 times 3 in this case, all right? So this is what you're going to have in the first bracket, minus, in place of x, you're going to substitute a 1. So this is 5, the ln of 1, plus, in place of x, that's a 1. So 6 times 1, guys, that's simply a 6. So simplify everything. That was going to be 17,493 units. Just like that. You've got simplified with the limits that you are given. 5.4, you're asked to draw the 2 sketches of these graphs. Calculate the points of intersection. All right, so let's see, because these 2 graphs, they will intersect at a certain point. So if you are to consider the first graph that we are given, it's 5.41, you're just going to have a sketch in that case. If you are to consider the first function that we are given, that's a quadratic, a parabola, y is equal to minus x squared plus 4, where the y-intercept is on a condition where x is equal to 0. When x is a 0, y is what? Y is 4. So the y-intercept was going to be a 4. And for the x-intercept, remember, y is supposed to be a 0. So if 0 is equal to minus x squared plus 4, what will be the values of x? Take to the other side. X squared is equal to 4. Square root. So x was going to be plus or minus 2. So x was going to be, we've got a negative value and a positive value. So this is what we're going to have, something like this. So that is our function in that case of y is equal to minus x squared plus 4. Then a linear function y is equal to x. It is the one, this type is the one that divides our graph into 2 equal parts, passing through the origin. So this one, it passes through the origin, dividing our graph into 2 equal parts. So that is the line of y is equal to x. So with this part, we are asked to draw these graphs. As you can see, these 2 graphs, they do intersect. At this point, we need the x value corresponding there. At this point, we need the x value corresponding. That is why they are saying calculate the point of intersection. Clearly indicate the area enclosed by the 2 graphs as well as the strip. As you can see, there's a region that is remaining in between, closed by these 2 graphs. They are saying present that so that you can use the strip. So the region that is indicated is this whole part, the area that you're talking about, covered by the 2 graphs. They're saying you must indicate the area, then a strip with respect to x. So we need the point of intersection. That is the one that is left. At the point of intersection, remember the 2 graphs are equal. That is for the points of intersection. So at the point of intersection, the 2 graphs are equal, meaning to say this graph of minus x squared plus 4 is equal to this graph. They will be equal. So you can solve for x. You now have a quadratic equation. Solve for x. So this is minus x squared, x to this side, it becomes a negative. Already there's a plus 4, which is equal to 0. We can avoid working with the negative, divide by -1, each and every term divide by a -1. So that was going to be x squared minus minus, that's a positive, plus and minus, that's a -4, which is equal to 0. There you have an equation that you can solve. As you can see, factorization was limited. We're not going to have factors here. So you can use the quadratic formula. X is equal to minus b, plus or minus the square root of b squared, minus 4ac, everything over 2a, where our a is the coefficient of x squared, b the coefficient of x, and c is the constant. So that's minus b minus 1 plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is minus 4. Everything over 2 times a, which is 2 times 1. So you're going to use your calculator there, guys, as usual. From your simplification, you're going to get 1.562, or another x was going to be negative 2.562. So these are the values that you are seeing at the point of intersection corresponding to this negative side. That is a negative 2.562. Corresponding to the positive side, that is where we are going to get the 1.562. As you can see, it corresponds below or before these two that we are given there. So that was the whole idea of this question. It's the whole idea. Sketch and present all that. Then after this, you need now to calculate or to determine, using integration, the magnitude of the area indicated in question 5.4. The area. How are you going to calculate the area? Remember, the area, there are two functions, two graphs to be considered there. So our area is going to be the difference, as you can see, because of the limits, which are for x, these limits, the points of intersection. It follows that our area with respect to x, so that was going to be 5.42, is going to be the difference between the two functions y1 and y2, the one on top minus the one below. So you're going to have y1 minus y2 with respect to x, our limit is taken from a to b, which is at the point of intersection. So at the point of intersection, So that is what you're going to have. So there's minus 2.562. And this one, it was going to be 1.562. y1 minus y2, that's the difference of the upper minus the bottom, which is minus x squared plus 4, the one on top, minus this one, which is below, which is x. So you're going to subtract x from this. So this means we're going to remain with what? Minus x squared minus x plus 4. So this is what you're going to have by subtracting y1 minus y2. With this, we can integrate. Substitute the limits that you're given, we're done. So let's integrate each and every part that we are given. Remember our integral, add 1 on the exponent. So the integral there, gonna add 1 on the exponent, that will be a 3. So that's minus x to the exponent of 3 over 3. Minus, add a 1 here, so that will be x squared over 2. The integral of 4 with respect to x, that's a constant, so it will be 4x. And the limits being given as minus 2.562 and upper limit as 1.562. So remember, you have to substitute upper limit minus the lower limit. What is on the upper limit minus this on the lower limit in place of x? So meaning to say, our area with respect to x was going to be, you're going to have minus, in place of x, substitute the upper limit, 1.562 to the exponent of 3 over 3, minus, in place of x, 1.562 to the exponent of 2 over 2 plus 4 into 1.562 in place of x. So this is the upper part of our calculation. Minus, we do the same thing on the lower when x is minus 2.562. Place of x, that's minus 2.562 cubed over 3 minus x squared, which is minus 2.562 squared, everything over 2 then the other part is plus 4x, plus 4 into our x, and our x is minus 2,562. So just like that, you substitute upper limit minus what is on the lower limit. That was going to give us the area with respect to x. So simplify this. You're going to obtain something like 3,758. And this other part was going to give us a negative 7,924. So simplifying these together, negative, negative, that's a positive. So that's we've got area with respect to x, which is 11,682 square units. So as dealing with area is measured in square units. So this is what you were actually supposed to have or obtain in this question paper. Just have to make sure you revise as much questions as you can on integration, derivatives, each and every topic, as you also consider the weight of each topic. Integration, 25, the derivatives, as we saw, 25. So that alone, if you can answer 2 questions, guys, just look, 2 questions, you're already at 50 by understanding that it can be very helpful. Then the integration, 20 marks. So let's just try to work out as much questions as we can and going through our normal part of those complex numbers, the use of the Cramer's rule. Let's revise as much as we can. So this is what we had, guys, till we meet again.